day, everyone. I am Novimi Siliakay Rocco, a fourth-year criminology student of Hingog City Colleges. So today, I am going to discuss to you what is ballistics. So now, let's proceed to our formal discussions. So what is ballistics? Ballistics is coming from the Greek word ballin or to throw. It is the science that deals with the motion, behavior, and effects of projectiles, especially bullets, gravity bombs, rockets, or the like. The science or art of designing and hurling projectiles as to achieve a desired performance. A ballistic body is a body which is free to move, behave, and be modified in appearance, contour, or texture by ambient conditions, substances or forces, as by the pressure or gases in a gun, by rifling in a barrel, by gravity, by temperature, or by air particles. It is a science in itself because it evolved from systematic knowledge, research and development, training experience, and education of those who pioneered in this field. Technically speaking, it refers to the science of firearms identification, which involves the scientific examination of ballistics exhibits such as fired bullets, fired shells, firearms, and allied matters used in crime. Legally speaking, ballistics is the microscopic examination of fired cartridge, cases, and bullets together with the recording and presentation by means of photography of what is revealed by the microscope. Ballista is a gigantic bow or catapult which was used to hurl large objects such as stones at a particular distance to deter animals or enemy forces. Ballistic theory. Ballistics is the scientific study of the propulsion and motion of projectiles such as bullets, artillery, shells, rockets, and guided missiles. Also include the study of the destructive action of such projectiles. The drag of a projectile moving head-on is now usually divided into three parts. So number one, the bow resistance, due to air pressure at the head of the projectile. Second, skin friction, caused by the friction of air moving along the middle portion of the body. And third, base drag, due to the under pressure and disturbance of the air behind the base. So, ballistics, it is sometimes subdivided into 1. Internal ballistics, 2. Transition ballistics, 3. Exterior ballistics, and lastly, terminal ballistics. First, let's tackle the interior ballistics. It is the study of motion of projectiles within the gun barrel. The time during which the projectile is influenced by interior ballistics is very short. From the release of the firing pin to the moment the sound of the shot can be heard as it leaves the muzzle occupies only about 0.01 seconds in a modern rifle. Interior ballistics involves 1. Ignition of the primer, 2. Flames is produced, 3. Combustion of the gunpowder, 4. Energy that is generated, 5. Force or pressure developed, 6. Velocity of the bullet from the chamber to the muzzle, 7. Rotation of the bullet, 8. Engraving of the cylindrical surface of the bullet. The personalities of interior ballistics. First is Benjamin Robbins. The British engineer Benjamin Robbins conducted many experiments in interior ballistics. His findings justly entitle him to be called the father of modern gunnery. Second, Benjamin Thompson, an Anglo-American physicist in late 18th century. He made the first attempt to measure the pressure generated by the gunpowder. The account of his experiment was the most important contribution to interior ballistics that had been made up to that time. In 1760, French balleticians determined the relationship of muzzle's velocity to the length of barrel by measuring the velocity of a musket ball and cutting off a portion of the barrel before taking the velocity of the next shot. So here are the related terms in interior ballistics. So first is the action, term referring to the mechanism of a firearm. Second, the burning rate, an arbitrary index of the quickness that burning propellant changes into gas. Burning rate is controlled by the chemical composition, the size and the shape of the propellant grains, and the pressure at which the burning takes place. IMR 5010 powder is very slow burning and bullseye is fast burning. 3. Bulk density. The ratio of the weight of a given volume of powder versus the weight of the same volume of water. 4. Chamber pressure. The pressure generated within the chamber, erroneously called breech pressure. 5. Charge weight to bullet weight ratio. This is the ratio of the weight of the powder charged to the weight of the projectile. 6. Denutation chemical. Rearrangement of molecules into gas instead of solids to cause the high explosive to exert full power of shocks. The speed of denutation varies in different explosive, but in some it is high as 7,000 yards in seconds. 7. Energy is measured in foot-pounds, and 1 foot-pound means that amount of energy which would be capable of lifting a weight of 1 pound through a distance of 1 foot drop block action. That type of action in which the breech block rises and forces vertically in cuts in the receiver side's walls. Lever equated as a rule. 8. Expansion ratio. The ratio of the capacity of the powder chamber plus pour in grains of water to the capacity of the powder chamber in grains of water. 9. Foot-pound. The amount of work required to raise 1 pound 1 foot high against the force of gravity. 10. Foot-second. Velocity expressed in foot per second. 11. Gas. A fluid resulting from the combustion of gunpowder with a relatively great expansion and spontaneous tendency. 12. Hang fire. Occurs when a cartridge fails to explode on time or delayed in firing. 13. Knocking power. The knocking power of the bullets, which delivers a very heavy, paralyzing blow that pulls the victim down and may then recover if the wound inflicted upon is not fatal. 14. Loading density. The ratio of the weight of the powder charge to the capacity of the powder chamber or cases. It is usually expressed as the ratio of the charge with weight to the capacity the powder chamber is grains of water. Generally, the more fully the power charge fills the case, the more consistent and accurate the load will be. On the other hand, if the loading density is too slow, too much to free space in case, it can cause erratic ignition, change in the pressure curve, moving the peak towards the muzzle, or even overly rapid burning or denutation of the other powder charge. One reason manuals list minimum or starting loads. 15. Misfire. Total failure of a cartridge to discharge. This is different from hang fire, which merely a delayed combustion, while misfire a complete failure even to start combustion. 16. Powder chamber capacity. As with most interior ballistics capacity measurement, it is usually expressed in grains of water. It is determined by measuring the weight of water that a fired case from the test firearm and can contain with a bullet seated to its normal depth. Note that this varies with different bullets or seating depths as well as the dimension of the chamber and the brand of case. 17. Pressure outward. Push of gases from powder combustion against cartridge case, chamber, and bore. 8. Sectional density. The ratio of the bullet's weight in pounds to its diameter. 19. PSI or pounds per second square. It is often seen designated as PSIA. This designation is now used to signify a measurement of chamber pressure taken with a piezoelectrical device. Piezoelectric units operate in a similar fashion to the copper crushes units but use a reusable crystal crusher that change its electrical properties in response to pressure. When connected to suitable recording equipment, the entire pressure pulse history can be recorded or displayed. The peak pressure recorded by a piezoelectric peak device usually reads about 5,000 psi higher than the figure determined by the copper crusher method. 20. Recoil. The equal and the opposite reaction of the gun against the forward movement of the bullet during the explosions. 21. Residual pressure. The pressure remaining in the chamber after the bullet has left the barrel. Second is the transitional ballistics, also known as intermediate ballistics. The study of the projectile's behavior when it leaves the barrel and the pressure behind the projectile is equalized. It lies between internal ballistics and external ballistics. Third is the exterior ballistics. Exterior ballistics deals with the motion of projectiles from the time they leave the muzzle of the firearm to the time they hit the target. The flight of most bullet or projectile does not exceed 30 seconds at maximum range, which for almost any firearm is obtained at an elevation of 33 conditions refers to the natural laws. A. Velocity. Speed per unit of time. Example, M16 is 3,300 per second. B. Energy. Fatal equivalent of a bullet. C. Yaw. The unstable rotating motion of a bullet. D. Gyroscopic action refers to the stillness of its rotating motion and attend its highest momentum or stability in flight and penetrating power. In exterior ballistics, elements such as shape, caliber, weight, initial velocities, rotation, air resistance, and gravity help determine the path of a projectile from the time it leaves the gun until it reaches the target. Further, exterior ballistics or external ballistics refers to the attributes and movements of the bullets after it has left the gun muzzle. It includes A. The muzzle blast, the noise created at the muzzle point of the gun due to the sudden escape of the expanding gas coming in contact with the air in the surrounding atmosphere at the muzzle point. Second is the muzzle energy generated at the muzzle point. Third is the trajectory, the actual curve path of the bullet during its flight from the gun muzzle to the target. The following are the kinds of trajectory. So first is the straight horizontal line, second is parabola-like flight, and third is the vertical drop. Fourth, range, the straight distance between the muzzle point at the target. It includes the accurate effective range, the distance within the shooter has control of his shots, meaning he can place his shots at the desired spot. Next, or second, is maximum range, the farthest distance that the projectile can be propelled from a firearm. While the range at which the ordinary pistols and revolver are supposed to be effective in only 50 to 70 yards, all of them can send their bullets much further than that and are capable of inflicting fatal wounds at distances up to 1 mile, depending on the caliber and gunpowder content. Fifth, velocity, rate of speed of the bullet per unit of time. Long barrel rifle up to 3,000 yards accurate range and its hinge muzzle velocity of 1,000 to 4,000 feet per second. Bullets from rifled weapons spin up 2,000 to 3,000 revolutions per second, but over the first few yards of the trajectory distance varies with the weapon. Their flight is slightly unstable. The end of the projectile wobbles before it picks up to the smooth flight path. This phenomenon is called tail wag and is of considerable importance in evaluating gunshot wounds. A bullet with tail wag does not strike its targets clearly. 6. Air resistance. Air resistance is a resistance encountered by the bullet while in flight. 7. Pull of gravity. Downward reaction of the bullet while in flight. 8. The penetration. Depth of entry on target. So here are the terms in exterior ballistics. First is the accurate range, the maximum distance at which a particular gun and cartridge will consistently place all shots in the standard target for the distance. Second, accurate range, the distance within which the shooter has control of his shots. Third, back curve. This is that portion of the bullet's trajectory that drops below the critical zone beyond the point blank range. Past this point, the trajectory begins to drop off very rapidly with range, and the point of impact becomes very difficult to estimate. 4. Ballistic coefficient. The means that the bullet may lose its speed very rapidly during its flight in the air. This is a number that relates to the effect of air drag on the bullet's flight and which can be used to later predict a bullet's trajectory under different circumstances through what are called drag tables. 5. Bullet energy. The power possessed by the moving bullet, or in other words, its ability to keep going when it meets an obstacles and to do work on the obstacles, is immense importance, for obviously the more power a bullet has and the harder it is to stop, to more effective it can be as a weapon. 6 is a bullet trajectory. This is a bullet's path as it travels down range. It is parabolic in shape, and because the line of the bore is below the line of sight at the muzzle and angled upward. The bullet's path crosses the line of sight at two locations. 7. Critical zone. This is the area of the bullet's path where it neither rises nor falls greater than the dimensions specified. Most shooters set this as 3 to 4 from the line of sight. Although other dimensions are sometimes used, the measurement is usually based on one half of the vital zone of the usual target. Typical vital zones diameters are often given as 3 to 4 for small game and 6 to 8 for big game and anti-personnel use. Drift. This is the curve taken by the bullet while in flight. A right-hand rifling curves the right to while that to the right, while that of the left and rifle curves to the left. 9. Effective range. The maximum distance at which a bullet may reasonably be expected to travel accurately and kill a particular type of live target. 10. Extreme range. The greatest distance the bullet will travel when the cartridge is fired. 11. Flat trajectory. A comparative term used to indicate very little curvature in the flight in the bullet from the muzzle to the point of impact. When the velocity is high, comparatively flat trajectory. 12. Gallery range. The indoor target range. National Rifle Association of America gallery rules requires stance from firing point to the target of 50 feet or 75 feet for 22 rim fire rifle, 50 feet or 60 feet for 22 rim fire pistols. On properly constructed indoor range, firing may be conducted with center fire pistols and revolvers at ranges of 25 yards and 50 yards. Such installations are generally referred to as indoor range, the term gallery being applied usually only to short range 22 caliber installation. 14. Instrument velocity. The velocity of a projectile measured by the scientific instrument called chronograph at the specified point on its trajectory, always lower than the muzzle velocity. 15. K-hole shot. The tumbling of the bullet in its flight and hitting the target sideways as a result of not spinning on its axis. 16. Maximum point or black range. This is the farthest distance at which the bullet's path stays within the critical zone. In other words, the maximum range at which you don't have to adjust your point of aim to hit the target's vital zones, unless there is some other overriding reason to the contrary. Shots should not generally be attempted must pass this distance. In the words of Guru, it is unethical to attempt to take game beyond 300 meters. If you do, you should write yourself a letter explaining why it was necessary to do so. An approximate rule of thumb says that the maximum point blank range is approximately your zero range plus 40 yards. 17. Maximum range, the farthest distance that a projectile can be propelled from a firearm. 18. Maximum ordinate. This is the maximum height of the projectile's path above the line of sight for a given point of impact and occurs somewhat past the halfway point to the zero range, and it is determined by your zeroing range. 19. Mid-range trajectory. This is the height of the bullet's path above the line of sight at halfway to the zero range. It does not occur at the same range as the maximum ordinate height, which can be greater. 20. Minute of angle or MOA. A minute of angle is 1 per 60 of a degree, which for all practical purposes equates to 1 inch per 100 yards of range. This one MOA at 100 yards is 1 inch, and at 300 yards is 3 inches. The term is commonly used to express the accuracy potential of a firearm. 21. Point blank range. Popularity used to indicate the distance the bullets will travel before it drops enough to require sight adjustments. A shot fired so close to the target that no sighting is necessary for effective aiming. 22. Ricochet. The bouncing off or deflection of a bullet from its original trajectory or normal path after striking a resistant surface. So, 22. Shocking power, the power of the bullet that results in the instantaneous death of the victim. 23. Stopping power, the power of the bullet that put the victim out of action instantly. So it should be understood that stopping power is not necessary to the same thing as killing power. However, stopping power depends very largely on the location of the shot. 24. Target, an object at which the firearm is aimed and discharged. 25. True drop, the actual distance the bullet falls during the time of flight to the target. This is not the same as what we speak of when we discuss drop in the ordinary sense, which is more improperly termed effective or apparent drop. 26. Zero range. This is the farthest distance at which the line of sight and the bullet's path intersect. Last but not the least is number 4. Terminal ballistics. It is the study dealing with the effect of the impact of the bullet on the target. Penetration of the bullet is of prime interest. Penetration is important also in determining safety requirements for target backstops. They are important to both sportsmen and military. Terminal ballistics involves, first, terminal accuracy, size of the bullets grouping on the target. Second, terminal energy, energy of the projectile when it strikes the target, also known as the striking energy. Third is the terminal penetration, depth of the entry of the bullet in the target. Fourth, terminal velocity, speed of the bullet upon striking the target. Terminal ballistics also deals with the destructive actions and effects that occur at the end of the projectile's flight as an integral and undeformed body. The flight may end in one of two ways. The projectile may strike as a solid obstruction, or its metal case may be broken by the explosion of a bursting charge. Shot ballistics deals with the attributes and properties of shots and pellets. Choke. When the diameter of a barrel of the shotgun is the same throughout the bore, it is called true cylinder. The bore of the gun is sometimes constricted near the muzzle end, that is, the diameter near the muzzle end is slightly smaller than the diameter of the bore of the rest of the barrel. The barrel is said to be choked. Full if reduced by 1 mm, half is reduced by 1/2 mm, quarter if reduced by 1/4 mm, and improved cylinder if reduced by about 1 per 10 mm. The amount of spread in the shot is controlled by choke. If a barrel will put 70% of each shot charge in a 30-inch or 60 or 76 centimeter circle at 40 yards or 37 meters, it is called full choke. Modified choke will deliver about 60%. Improved cylinder about 50%. A full choke 20 gauge gun will kill ducks that are about 60 to 65 yards or 55 to 59 meters away. Chilled shot. Shotgun pellets made from lead, specially hardened by the addition of a slight armed or antimony. Wound ballistic. It is the study of the effects of projectiles to human body. Gunshot wound or GSW. It is an open wound produced by the penetration of bullet slug within the tissues of the body. The bullet which was propelled from the gun as well as the flame from the heated expanded gases in short-range fire is the one that produces injury. So that's all, and thank you for listening. I hope you will learn something.